So best way to do this is just look at it's Badoo questions. Okay, so this is an extended ACL. So an extended ACL is it's like a poor man's firewall that you have on a Cisco router, and it can filter traffic based on source IP, destination IP, protocol, port number, application. Really, anything that can be, anything that can be filtered can be done with an ACL. So we have this question here. So it's configure an extended ACL. Well, configure an ACL to only allow HTTP access. So once you see that, it can't be a standard ACL because a standard ACL only filters on source address. So configure an extended ACL to only allow HTTP access from 192.168.1.2, so this guy here, to 192.168.3.2. No one else should be able to access 192.168.3.2 over HTTP and permit all other traffic. So there's your three statements. So remember a couple of these rules, okay? And this is kind of like a hint to the actual question you're going to be doing shortly. Okay, so the two main rules are you need to put your ACL as close to the destination as possible. If you do that, as close to the destination interface as possible, if you do that, it will always be in an outbound direction. Okay, you will always be telling the router to filter it in an outbound direction. Okay, so how do you know where the source and destination is? Well, look at it. It tells us from 192.168.1.2 to 192.168.3.2. No one else will be allowed access 3.2 over HTTP. Permit all other traffic. Okay, so this is our destination here, and the interface that is closest to the destination is going to be 3.1. Okay, so another hint as well is really, really useful is always, and this isn't a hint, this is really what you should be doing. Always put most specific rules on top. The most specific rules on top in your access list. So let's create an ACL here. We'll call it 152. Yeah. So which is the most specific rule? Well, if you look here, HTTP access, which is what? This is going to be TCP port 80 from one device to one device. That's very specific. No one else will be allowed access this device over TCP port 80. It is specific, but it's not as specific as the top one. And allow all other traffic is the most general. Okay. So we're going to do it on the Dublin router. Now, before we do that, let's just have a look at, so 192.168.1.2 is here. Let's see if we can, actually, let's see if PC1 here is allowed access 3.2 over HTTP. Go into desktop, go to web browser, and we just HTTP 192.168.3.2, and we are. Cool. Okay, so after we do this, after this access list is applied, this PC here, PC1, will not be allowed access 3.2 over HTTP. Where does it say that? Well, it'll have it in this rule here. No one else will be allowed access 3.2 over HTTP. Okay. So we'll go into the Dublin router. And we'll create our ACL. Enable CISCO as password, big space T, and I'll put this up here. Okay. So, no, first one here, only allow HTTP access from 192.168.1.2 to 3.2. So, access list, question mark, is an extended or a standard, has to be an extended. So any number between 100 and 199. So access list one, what did we say? Was it going to be 152? Then what are we doing? Question mark. Deny, permit, or remark. We're going to permit. Only allow. What are we doing? What are we permitting? HTTP access. HTTP is not here because this is only covering, this is specifying layer 4 protocols. So TCP port 80 is HTTP. So we have to mention this TCP protocol here. So allow the TCP protocol. Then we put in the source device, which is host. One device is a host. So we say host 192.168.1.2 going to host 192.168.3.2. Now, if we press enter there, that will allow all TCP traffic. We don't want this specified in all TCP traffic. We want this rule here to be HTTP traffic from 1.2 to 3.2. So we're going to have to do TCP equal 80. Match only packets on a given port number. Again, we went through all of this yesterday. I'm just going through as just a refresh. Okay, any questions with that one? All right.
All good.
No one else will be allowed access 192.168.3.2 over HTTP. So access list 152. No one else is denied. Again, TCP protocol. Coming from no one else means any. Where are we going to? 192.168.3.2. So it's any to host 192.168.3.2 equal 80. Once you specify, it'll always be equal. Here, it'll always be equal. For CCNA anyway. So access list 152, deny TCP any host 192.168.3.2 equal 80. And the last one is allow all of the traffic. Well, you just need to learn this one here. Access list 152 permit IP any to any. So that means basically permit IP. Remember, IP covers everything. It's a protocol that covers all traffic. I mean, IP any space any. So that's still not going to work though. Why? 192.168.3.2. Because there's one part is creating the access list. The next thing you need to apply to an interface. So we've created the ACL, but it won't come into effect until you apply to an interface. So exit. Show IP in brief. We need to apply to interface FA0/0. Backspace T into FA0/0. IP access group 152 and outbound. That's it. IP access group 152 out. All done. So check that out. Go back in here. Let's try 192.168.3.2. Timed out. So what rule is that being blocked on? It's been blocked here. Yeah. So let me just do a quick screen grab here, snippet. So in order for an access list, in order for a rule to be implemented, everything must match. So we're looking at, so let's say this guy here, this PC wants to HTTP onto 3.2. So the source IP address will be 1.3, 192.168.1.3. The destination IP address will be 3.2, and the protocol is TCP port 80, which is HTTP. So this is going to go across over into the Dublin router. Then the Dublin router is going to look at this rule, these rules down here, and it's going to say, okay, configure an ACL to only allow HTTP access from 1.2. So it's going to say, are you the source 192.168.1.2? No, 1.3 is not 1.2, so there's no match. When there's no match, it doesn't look at anywhere else on that line because it can't be that rule. In order for this traffic to be allowed, the action means allowed, then everything must match. So it goes on to the next line. So it says no one else. Well, this means everyone is going to be denied, yeah? So are you part 1.3 is part of everyone? Yes. Are you going to 3.2? Yes. Are you TCP port 80? Yes. Well, then you're going to be denied. Okay. So that line there is what is blocking PC1 from accessing 3.2 over HTTP. Any questions on that?
No.
Okay, so do you want to download this, go into day 9, ACL's extended ACL lab, and we'll have a look, and I get just to do this exercise. This is a new one here. So using the same lab, using the same diagram or topology, there we are. So we have this access list here. We need to create an extended ACL with 3 statements. Okay. So basically it says no one is allowed access 192.168.1.2. Where is 1.2? Any access. We're not just talking about HTTP. We're talking about all communication. No one is allowed access this guy here except for 3.3. Permit all other traffic. Now the thing is, you cannot do this in less than 3 statements. It will take you 3 statements. So what you need to do is, this line here needs to be divided into your 3 statements. Okay. Once you have your 3 statements, then you need to put it in the correct order. Remember, most specific rules on top. Most specific rules on top, and always put ACL as close to the destination interface possible, which will be going in the outbound direction. Any questions on that, guys? Just want to have a go with that? Everyone's gone all quiet.
Yeah, we'll have a go.
Give it a go.
Yeah, okay. And again, any questions, let me know, okay? You know, we'll get, maybe we'll allow 15 minutes for it. We'll see where you are at 8:30, okay? So take this. So this is it here. No one is allowed access 192.168.1.2 except for host 192.1. Well, do you want me to put in the commands for the last access list on the screen? Will that help you or will that hinder you?
think it might help.
Okay, so this is just a sample one here. I'm going to put down on the screen. This will just give you the format of the commands. Okay, you know, you need to. This is not the right access list. This is wrong because you're talking about TCP port 80. All traffic is going to be IP. So open up this packet tracer lab, keep this on the screen here. This is a sample ACL. You can use this sample one to just give you the kind of format in which you need to put everything in. But straight away, you know it's not going to be on the Dublin router because the destination is 192.168.1.2. So you need to take this line and divide it into 3 separate statements. One access list with 3 statements. One access list with 3 rules. That makes sense? Like this is one access list here, but there's 3 rules. 1, 2, and 3. Okay, I'm going to pause the video and have it. So there's your 3 statements. Just kind of detangled. So no one is allowed access 192.168.1.2 would be this one here, deny IP traffic from anywhere to host 192.168.1.2, except for host 192.168.3.3. So basically this here is saying 192.168.3.3 is allowed access 192.168.1.2. So you'd say permit IP coming from host 192.168.3.3 to host 192.168.1.2. And then permit IP, permit all other traffic is permit IP any. So there's your 3 statements. They're a little bit rough, but they're the 3 statements in a nutshell. Now remember, you have to put most specific rules on top. So which is the most specific rule?
One of the 2 IPs, isn't it?
That one there. So this one here is going to go on top. Because you're saying permit this device access to this device with IP protocol, basically allow all traffic. And then it's basically saying this one here saying deny everything else traffic to this host here and permit IP any, which is allowing all other traffic in. Okay, so let's apply it. So where we need to apply it to 1.2, we need to apply it on the Cork interface marked 1.1. I'll just get rid of this part here. Actually, 1 second here. Okay. So go to CLI, enable. What you do is show IP in brief. Okay, we need to apply it to FA0/0, yeah. So config space T, access list. Let's say any, so it'd be any number between 100 and 199. So we say access list 165. What are we doing? We're saying permit or protocol IP coming from host 192.168.3.3 going to host 192.168.1.2. That's done. The next line, access list 165, deny IP coming from anywhere to host 192.168.1.2. Then the next line, access list 165, permit IP any to anywhere. So there's your 3 statements then we need to go into the interface FA0/0 and apply that rule. Int FA0/0 IP access group 165, and the direction is going to be outbound. Okay. Is that okay, guys?
Yep.
Cool.
Yep.
All right.
Well, if you just show the diagram there, will 1.3 not be able to reach it? They're in the same network.
Well, oh yeah, 1.3 will. Yeah. 1.3 will be allowed access 1.2 because they're in the same network. Yeah. If you wanted to prevent 1.3 from accessing 1.2, you would have to create VLANs on the switch. And you'd have to create VLANs and then router on a stick. And then you can apply your access list to router on a stick. That makes sense? Okay, so want to configure I want to talk about configuring OSPF multi-lab. So what to do is just open up a new version of Packet Tracer. Okay, and we're going to grab maybe 2 routers. Okay, R1, R2, and R3. We'll try with we'll try and do this here. So let me know if I'm going too fast. So grab 3 routers. Use 1941s. 1, 2, and 3. Okay. R1, R2, and R3. Okay. The router, the link here between R1 and R2 is going to be area 0. Okay, so what we're going to be doing is going to be doing this lab here. Actually, what you can do is if you go into Dropbox and go into day 8, and this is really useful if you've got 2 screens, we're going to set up R1, R2, and R3. And then if we have time, R4. Okay, but we do R1, R2, and R3 first. Okay, and we'll try and do it as close to this as possible. Okay, so connect R1 to R2 by using gig 0/0 to gig 0/0. So we'll put gig 0/0 to gig 0/0. And then R1 to R3 is going to be gig 0/1 to R3, it'll be gig 0/0. Gig 0/1 or 3's gig 0/0. Okay. The network's addresses is be 192.168.8.12.0, and this is 192.168.13.0. Okay, if you have a look at the diagram, sometimes I do it, it's a good way to do diagrams this way. If you're doing your labs, have R1, R2, and R3, yeah? Then the network between R1 and R2 is 192.168.12.0. Why? Because you're linking R1 to R2. So the third octet tells you you're going from R1 to R2, which is 12. 12.1 is R1, 12.2 is R2, because R2 is .2. Then if you look at R1 to R3, it's going to be 13.0. Why? Because you're linking R1, which is 1, to R3, which is 3. So the third octet is 13. Does that make sense? R1 is 13.1, R3 is 13.3. Why? Because it's R3. Okay. Now here, what we're trying to do is we're not the packet tracer. This is FA 0/0, but packet tracer, these 1941 routers are only gig 0/0 and gig 0/1. So we are replacing FA with gig links. Okay. So we're going to R1 and we're going to configure the CLI, no, enable, config space T, hosting space R1, int gig 0/0, IP address 192.168.12.1, 255.255.255. And these, they're /24s. Yeah. That's 0. No shot. And then int gig 0/1, IP address 192.168.13.1, 255.255.255.0. No shot. So there's our one done. Give us a minute to type that in. Let me know when you're finished and we proceed to configuring IP details on R3. Let me know when you finish that, guys.
Yep, done.
Okay, cool. Good stuff. Okay, we'll go into R3 then. Is everyone finished? Or will I give it another minute? Okay, go to R3. CLI. No. Enable. Config space T. Host namespace R3. No, not R3 even. Interface gig 0/0/0. IP address 192.168.13.3. 255.255.255.0. No shutdown. Now this link should go green. Yeah. Let me know when that's finished, guys.
Lee,
Yes, Edmund.
you put in router 13 host name router
Sorry,
3.
no, it'd be hostname R3.
Yeah,
Just
but
ignore that.
the beginning. Look at the
Yes.
beginning.
That was a typo.
Okay.
Yeah.
Done.
Good stuff. Okay, so we'll go into the last one, which is R2, CLI, no, enable, config space T, hostname R2, interface gig 0/0, IP address 192.168.12.2, 255.255.255.0. No shutdown, and that link should go green. Okay, there's the commands then for R2.
All good.
Good stuff. Okay, great. Okay, so let's start configuring OSPF. So we'll start at R3. Yeah, and what we're going to do with R3 is we're just going to give it a name first. Again, okay, so we're going to give it, we'll give it a loopback before we do anything. So interface loopback 0, IP address 3333 255 255 255 255. So we're going to create. So again, if you have a look at the diagram here, we're having a loopback on R3 3333. The loopback on R1 1111. The loopback on R2 2222. So interface loopback 0, IP address 3333, exit, and then we're going to say int gig 0/0 IP OSPF. Process ID is 1. Area is going to be, well, what area is this? Area 1. So we're going to say area 1 here. IP OSPF 1, area 1. Okay. Exit. We're going to go into R1. Is that okay, guys, in that?
Yeah.
Yep.
Exit.
Just for 1 second.
Sorry, yeah. This here, is it?
Yes, please.
Sure, no problems.
Cheers. Thanks.
No problems. Okay, then we're going to go into R1. Interface loopback 0. IP address 1.1.1.1. 255, 255, 255, 255. Exit. Int gig 0/1 IP OSPF. Process ID 1, area is 1. Okay, so gig 0/0. So this in red are going to be area 1. Okay. Again, so it's the interfaces that you put in area 1. Actually, that's different to the diagram I had up there a second ago, didn't I? Yes. So yeah, this here is area 1. Gig 0/1 and R1 is area 1. Gig 0/0 and R3 is area 1. Gig 0/0 on R1 is area 0. Gig 0/0 on R2 is area 0. Does that make sense?
Yep.
Okay. So we're going to go into R1, and you can see here, we're already neighbors with 3333, which is R3. So we need to be neighbors with R2 now. So we exit out, int gig 0/0, IP OSPF 1 area 0. Now we need to go into R2. Exit, interface, loopback 0, IP address 2.2.2.2, 255, 255, 255, 255. I might just do this interface IP OSPF 1 area 0. Exit, because I'm going to put the loopbacks also in OSPF. Interface gig 0/0, IP OSPF 1 area 0. We should be, there we are. We're now neighbors. Which you should be seeing. What I'm going to do, if there's problems with this, I'm going to create this lab and I'm going to put it in here and I'm going to put in the commands to do this lab in the notepad. So I'm going to create this lab in Packet Tracer and I'm going to put it into Dropbox day 8. So you can actually see the commands. So now R1 should be neighbors with R2 and should be neighbors with R3. So if you go into R1, show IP OSPF neighbors, that's what you should see. So R1 is OSPF neighbors with R2, which is 2222, and R3, which is 3333. See, they give you the advantage of losing loopbacks and using the R1, R2, and R3. It's much more easy or then to identify. When I see 2222, I know straight away that's R2. When I see 3333, I know it's R3. 1111 is R1. Try and make it as easy for you as possible, you know. Is there anything there you want me to go over, guys? Now, this is still not going to work because I should have done this. I should go into each loopback and turn on OSPF, IP OSPF 1, area 1, or 1, interface loopback 0, IP OSPF 1, area 0. So I've just added those interfaces in to OSPF. So if I go into R3 now and do show IP root OSPF, to show IP root, oh, we should be seeing the other ones. So IP OSPF neighbors. Ah, there we are. You can see in here 2222 and 3333. So if I do show IP root OSPF, R1 knows about 2222 and it knows about 3333 from OSPF. If I do R3 and I do show IP root, okay, I need to add this one over here. Configure T, interface loopback 0, IP OSPF 1, area 0. So we'll go into R3 now. Do show IP route. Should know about this network here. You can see R1 is able to ping now. Ping 1.1.1.1. 1.2.2.2.2. And 3.3.3.3. So any questions on that, guys?
No, it's all good.
Okay, what I'm going to do is I'm going to create that lab in that diagram there, and I'm going to put up the full config for it. I'm just going to put in Notepad, and then you can just copy and paste in, and it should work. All right, guys.
Cheers.
Okay, so see you next week.
Yep.
Next Tuesday at 8 o'clock. We're looking at IPv6, so it's a good lab. Or it's a good, there's a lot of stuff to be involved in it. So if you can be around, please attend. All right.
Thanks a lot. Take it
Cheers,
easy.
mate.
Okay, guys. Cheers.
Thank
Thank you. Thanks.
Bye bye.
Bye. Bye.